Hey guys, welcome to question MM337 of the Maths Methods Fortify study guide. Now this question says, a water park on the Gold Coast has built a water slide which is modelled by the function h of x equals a outside of x take b cubed plus 10, where h meters is the rider's height above the ground and x meters is the rider's horizontal distance from point O. A and b are real constants. Awesome. So part A is a 2-mark question and says if h dash of 5 equals 0 and the slide starts 22.5 meters above the ground, show that A equals -1 on 10 and B equals 5. Awesome. So first things first, let's deal with this h dash of 5 first. So h dash of 5 is equal to 0. Now, whenever we say h dash of 5, we're saying that the gradient at x equals 5 is equal to 0, okay? Which means that our flat point, or our point of inflection, so point of inflection, occurs at x equals 5, right? Because our gradient is 0 at that point. So x equals 5 is here. And if our point of inflection occurs at x equals 5, because this is in power form, this cubic, that means that our b is equal to 5, right? So that means that h of x equals a x take 5 cubed plus 10. Okay, so that's our first mark. So finding that gradient is 0 and then finding that point of inflection there is our first mark. And our second mark will obviously come from showing that a is equal to -1 on 10. So from here we know that the second piece of information that it tells us in part A is that the slide starts 22.5 meters above the ground. Okay, so our y value is 22.5, so h of 0 equals 22.5. Right, because it starts at x equals 0, and that's where point P is. So therefore 22.5 equals a outside of x take 5 cubed plus 10. Awesome. So to get this by ourselves, going to minus 10 from both sides. So we get 12.5 equals a x take 5 cubed. And then from there, we're going to get 12.5 equals a, and then we need to sub in our 0 for x. I should have done that earlier, but I just didn't. So that's where we get this, and then we can say that a -5 to the power of 3 is -125. Dividing both sides by -125, get 12.5 over -125 equals a. Therefore, a is equal to -1 over 10. This is our second mark. So guys, that's it for part A. Let's move on to part B. Part B is simply a 1-mark question, and what we need to do, Awesome. What we need to do is find the coordinates of the points P and Q, the start and end points of the water slide. Cool. So we know that P is going to be 0, 22.5, because the question tells us that. It tells us that it starts at 22.5. So that's our first one, which is why this is only worth 1 mark, because the question kind of tells us what P is anyway. So Q, on the other hand, occurs on the x-axis, right? Which is when y equals 0. So 0 is equal to a, which is -1 on 10, outside of x minus 5 cubed plus 10. Awesome. Now from here we're going to minus 10 from both sides, so we get -10, -1 on 10, x take 5 cubed. Multiplying both sides by -10, we get 100 is equal to x take 5 cubed. And we get the cubed root of 100 equals x minus 5. So then x equals 10 to the power of 2 on 3, which is just this simplified. Can we use our CAS in this question? Yes. So you can simplify the cubed root of 100 in your CAS to 10 to the power of 2 on 3 plus 5, which means that Q occurs at 10 to the power of 2 on 3 plus 5, 0. And that is our first and final mark for this question. Guys, that's part B. Let's move on to part C. Part C is a 2-mark question. And tells us the wall under the water slide must be repainted due to wear and tear. The shaded region above is the section that needs to be repainted. So this shaded area here. find the area of the section that needs to be repainted, correct to 2 decimal places. Awesome. So we know that area under a graph, which is exactly what this is in this case, is equal to from the lower to the upper terminal of f of x dx, right? We all know that. So our lower bound is 0, because that's where it starts, and our upper bound is at q, which is 10 to the power of 2 on 3 plus 5, right? And then our function is negative 1 on 10, x take 5 cubed plus 10 dx. Sweet. Now you do have your CAS for this question again, so I would actually just chuck this in your calculator and then rewrite it as if you kind of figured it out, if that makes sense. So the next line of working, you would say that it's negative 1 on 40, x take 5 to the power of 4 plus 10x from 0 to 10 to the power of 2 on 3 plus 5. Awesome. Now, that's pretty much your first mark there, and then your second mark you're going to get for the final answer. So from here, it's best to kind of work this out as you go. So what we get is negative 1 on 40, outside of 10 to the power of 2 on 3 plus 5, minus 5. So this bit here is that x, and then we minus 5. That's to the power of 4, plus 10 outside of 10 to the power of 2 on 3 plus 5. That's that bit there. Then we minus negative 1 on 40, 0 minus 5 to the power of 4 plus 10 outside of 0. Awesome. Now, this is going to give us, correct to 2 decimal places, 100.44 meters squared. Now that's our second and final mark for this question, for part C. This is pretty much enough working, because here you're showing that you understand what's going on. You can do more working in between here, that's no problem, but that should be it. So guys, that's it for part C. Let's move on to part DI. Now part D is a 2-mark question, and says before they repaint the wall, they paint a line from O, 0, 0, to R, H of R, as shown below, where R is between 0 and 5. Awesome. Part I, so part DI, says find the length of the line OR in terms of R. Awesome. So, first of all, we know that our length formula, so to actually find the length of OR, actually, you know what, let's not do that yet. Let's just find the coordinates of R in terms of R. So we know that at this point our X value is R, but we don't know what our Y value is, so let's find that. So we know that H of R is going to be equal to negative 1 on 10, R minus 5 cubed plus 10, and then that's our Y value, right? So R occurs at R, negative 1 on 10, R minus 5 cubed plus 10. Awesome. So now, our actual length formula, so the length of OR is equal to x2 plus x1 squared, minus plus y2 minus y1 squared. Awesome. So our first x value is going to be R. Our second x value is 0, because that's at our origin, so that's squared, plus our first y value, which is h of r, which is this bit here. So we get negative 1 on 10, r take 5 cubed plus 10 squared. Minus our other y value, which is 0 in this case, so minus 0 squared. Now, that's up here is our first mark, so just here. And then our second mark comes when we finalize that and say that our length is equal to r squared plus negative 1 on 10, r take 5 cubed plus 10 squared. That's our second mark. So this is our length of OR in terms of R. Guys, that's it for part DI. Let's move on to part DII. Part DII is simply a 1-mark question and tells us to find the value of R if the length of the line OR is at a minimum correct to 2 decimal places. Awesome. So DII, 1 mark. Awesome. So if OR is at a minimum, that means that the derivative of that length is 0. Okay, so dLdr is going to be equal to 0, right? So we know that L is equal to the square root of r squared plus negative 1 on 10, r take 5 cubed plus 10 squared. And what we're going to do is find DLDR on our calculator. So you're going to go menu 41, and then chuck this bit in here, and find the derivative of that. And then we're going to solve for that equals 0. Right, so the derivative equals 0, and then, so solve. And then what we're going to come out with is r equals 3.87, r equals 6.50, and r equals 9.37. Now, the question tells us that r is between 0 and 5. So therefore, r is equal to 3.87, corrected through 2 decimal places, which is what we wanted. And that's our first and only mark for part D, I, guys. That's it. Let's move on to part D, I. Part D, I says that the park decides to paint the shaded section above in red. So just this section here. Find the area of the section which will be painted red, correct to 2 decimal places. Awesome. Part D, I. 2 marks. Alrighty, awesome. So whenever we've got an area under a graph like this, and it's split up into sections like this, we need to actually split this down the middle, okay? Well, not necessarily down the middle, but just at the point of the crossover. Because this line here and this line here are not the same function, okay? They're not the same, we're not gonna be able to do an integral of just this whole section, okay? Because they're different areas, right? So we're gonna split this. We're gonna say that this is A1 and this is A2, all right? So A1, as we can see, is actually a triangle, right? Because OR is a straight line. We've got a straight line coming down here and then a straight line across there, which makes it a triangle. So our total area, AT, total area, is A1 plus A2. So A1 is a triangle. So 1/2 times base times height. That's how we find the area of a triangle. Area 2 is the area from R to Q of h of x, right? So from R to Q of h of x dx. Now, the base is from here to here, which puts us at our R value, which is 3.87, right? We found that in the previous question. And then our height is the Y value at that point, all right? So h of 3.87. And then we're going to add our integral from R to Q, right? So R is 3.87. 3.87. And then our to our Q value is 10 to the power of 2 on 3 plus 5, which approximates to 9.64. Awesome. Of h of x, which is -1 on 10, x take 5 cubed plus 10 dx. This is our first mark. So getting all this there and getting all that down there is good. That's our first one. So then we can kind of start simplifying this. So we get 1/2 times 3.87 times h of 3.87. If we sub x of 3.87 into here, we get 10.14. And then if we evaluate all of this on our CAS, we get 46.13. Cool. So it's only a 2-mark question, so the working doesn't have to be like fully there, but you just need to make sure that you show that you understand what's happening. So then we get 19.64 plus 46.13, which gives us an area of 65.77 meters squared. Now that's our second and final mark for question MM337, and that's it for that one. Guys, if you have any questions about any of this, as always, please hit me up in the comments below. But otherwise, thank you very much for watching, and I'll see you in the next video.